Hello there, my name is Shannon Gracie, and this is the very first section of Chapter 1 using the Blitzer combo book for Introductory and Intermediate Algebra. So today, as you see, when you're done with your homework, you're going to be able to evaluate algebraic expressions, translate English phrases into algebraic expressions, determine whether a number is a solution of an equation, translate English sentences into algebraic equations, and evaluate formulas. So let's warm up, first of all, by performing these operations and simplifying. Now, just to let you know, these are a little, above your pay grade. We're going to be learning some of this stuff as we go along. But we might as well get started and challenge ourselves right off. So why don't you go ahead and pause this recording and try these warm-ups, see how you do, and then play it again to see the worked out solution. Good luck! All right, so here we go. Remember that negative 5 cubed is negative 5 multiplied to itself 3 times. So what we'll end up with here is the opposite of negative 125, which gives us a positive 125. We'll be reducing that by 3. And then 8 times 9 is 72. It's got a negative attached, so we'll have negative 72. And then we will have 122 when we do the numerator over negative 72. And then scrolling down, this is able to be reduced. So if you see here, we can certainly divide the numerator and the denominator by 2. And then we will end up with 61 over negative 36, which of course you can bring that negative sign to the front, and we would get negative 61/36. And this is the fully simplified expression. As I said, we are going to be learning about these topics as we go through the chapter, so if this seems a little mystifying to you, don't worry about it. Second one, remember that in the order of operations, division is higher on the hierarchy than subtraction. So really, we could write it like this, 16/5 decreased by 1. But now what we need to do is we need to get a common denominator so that we are combining like-sized pieces here. So we'll have 16/5 minus 5/5, which will yield a result of 11/5. And we'll just go ahead and leave these as improper fractions. All right, so now when we go down to evaluating algebraic expressions, we're getting started on the current material. So we can replace a variable that appears in an algebraic expression by a number. The process is called evaluating the expression. So here's a first look at our order of operations. You perform all operations within grouping symbols. So some grouping symbols that you're used to seeing are parentheses, square brackets, stuff like that. And that's usually what is done first, so such as parentheses. Do all multiplications multiplications in the order in which they occur from left to right. Oops, sorry about that. And then the third step, do all additions and subtractions in the order in which they occur from left to right. So here we go. With this first example, we want to find the mistake. You know, a lot of times it's useful. These evil math teachers try to sucker you into problems and to doing things that look like they'll work out great, but don't work out at all. For example, if you look at this problem following order of operations, really, what should be happening first? You know, should this division be happening? Should the multiplication be happening? Or should this addition be going on? So here, what do you think the mistake is? Take a look and then see if it matches up. All right, exactly. What you probably noticed here, when the person put 5 divided by 5, they did addition before division or multiplication, which was the error. So if we were writing out what happened, you know, this addition shouldn't have occurred. We should have divided first. Because really, division and multiplication are on the same hierarchy. Because division is defined by multiplying by the reciprocal. So what should have happened first was this here, the 2 divided by 5. All right, so second example here. We're evaluating this following algebraic expressions at the given values. All right, so here we go. Wherever we see an x in this expression, we're going to plug in a -2 and see what value this expression takes on when x is -2. So 2 times -2 plus 25 divided by -2 minus 1. So here, x is -2, so wherever there was an x, I plugged in a -2. So this will yield a result of -4 from the 2 times -2, increased by 25 all over -3, and this will be 21 divided by -3, which yields an end result of -7, and we're done. Okay, why don't you try the next one? Notice there's 2 different variables, all right? So go ahead and pause this movie and try the next one. All right, let's see how you did. So in this one, wherever there's an x, we're going to plug in a 10. And wherever there's a y, we're going to plug in -4. So we will have 6 times 10 minus 9 times -4 plus 1 all over -4 minus 10. So again, the y took on a value of -4. I've highlighted it in the yellow. And x took on a value of +10, which I've highlighted in the blue. So 6 times 10 yields a result of 60. Minus a minus is plus, so we'll get a plus 36 plus 1 all over -14. And this will end up being bring that negative to the outside, and we'll get 97/14. And that is our end result. All right, so next up, let's talk about some key words for addition, subtraction, multiplication, and division. So addition. Some words for addition are sum. Here's a hard one. Plus. Increased by. More than. Now you have to be careful. It's easy to confuse more than, with an inequality, which we'll talk about later. All right, so subtraction. Difference. Less than. Decreased by. And simply minus. All right, multiplication. Here, this little tiny word gets people all the time. Of. Of means times. Right? Product times. Multiplied by. Twice. All of those are examples of multiplication. Division. It's always, counting how many of one quantity are in another. So quotient is the word for it. Divided by. Ratio. These are all some key words for division. All right, next up, already on page 3. So here we go. Let's, translate this English phrase into mathese. So write the English phrase as an algebraic expression. I'll start off. 6 more than a number. Right? So 6 more than a number we could write as x plus 6. 12 less a number. What do you guys think that would be? You got it. 12 minus, whoops, making up my own math a little bit. We got to represent it as a number. So 12 minus x. The number can be x. How about 2 times the sum of a number and 5 increased by 9? So let's break this up a little bit. We can start with the sum of a number and 5. We start with the sum of a number and 5. We can write that bad boy as x plus 5. Put that in parentheses. So this is that portion of it. And then if we're saying 2 times the sum of a number and 5, we can simply multiply that by 2. Remember, if you have a number and then parentheses, that implies multiplication. Then if we want to say increased by 9, we need to go plus 9. So this last part, increased by 9, plus 9, and all the pieces go together. All right, so here we are with some equations. Right? It's very important to understand the vocabulary in math. I mean, the vocabulary is the framework of mathematics. So if you understand the language, you're going to understand how to work these problems much better. So an equation is a statement that 2 algebraic expressions are equal. So what symbol does an equation always contain? You got it. And equals sign. So this is the equals sign. All right, solutions of an equation are values of the variable that make the equation a true statement. To determine whether a number is a solution, substitute that number for the variable and evaluate each side of the equation. If the values on both sides of the equation are the same, the number is a solution. So let's check out example 4. Example 4, we want to determine whether the given number is a solution of the equation. So here we go. For this one, we have a variable x. So we want to plug in 5 where we see an x and see if it works out. So here, 5 plus 17, is that equal to 22? Well, here we get 22 equals 22. That looks true to me, right? So here again, we put 5 in for x. We completed the calculations and we got a true statement. So don't forget to answer the question. Yes, 5 is a solution. Of x plus 17 equals 22. So in your homework, they're just going to ask you for a yes or no, but I like to put the complete sentence here. All right, in this next one, x is now z rather, is the variable, and it's taking on a value of 8. So 5 times 8, is that equal to 30? So here's the value for our variable. We plugged in 8. So 5 times 8, don't use your calculators, just use your brain, is 40, isn't it? And 40 is certainly not equal to 30. Okay? So we would say, no, 8 is not a solution. Of 5 times z equals 30. All right, so example 5, they want us to write each equation now as an English sentence. So let's check out what we have going on. So I'm thinking that we can use some of our words here. So here we have a 9, right? So 9 less. So the less is coming from this. So 9 less is that portion. And then here, do you see we're going to have 3, and that operation's multiplication. So 3 times a number. In math-ese, the equals sign means is. All right? So the math version is equals, English version is. So we have the 9 less, the 3x can be read as 3 times the number, is the green, and then 7 is 7. All right. Now why don't you try number 2? See how you do. All right. So here we've got this quantity in the parentheses. So we'll start with our 2 times the sum of a number and 5. Is a number. Actually, we should probably be specific because it's the same number. So we should probably say is the number less 4. So let's match it all up. And I gotta put 2 times, not 2 times. So the sum of a number and 5 is this part of it. And then here we have the doubling, so 2 times. Then of course, equals translates to is. And this last part, we gotta get, this color is a little dark. So we'll go with, let's see how this one here works. So this here, the number less 4 is that portion. So just to, if you put all the pieces together, you get the end result. All right, next example. Whoops, I have the directions. We want to write each sentence as an equation. So here we go. The difference between 40 and a number is 10. So when it says the difference between and then it says the 2 numbers, you put them in that order and you put that operation in between them. So we put 40 and a number, difference is subtraction, is equals 10. Okay. So if you want to break it down a little, whoops, the difference between 40 and a number is this part, and then is 10 is that part. You can try the next one. All right, let's see how you did. The product of 6 and a number. So 6 times x, how that one translates. Increased by 3. So we're adding 3. Is 33. There we go. Okay. Formulas and mathematical models. One aim of algebra is to provide a compact, symbolic description of the world. These descriptions involve the use of formulas, A formula is an equation that expresses a relationship between two or more variables. The process of finding formulas to describe real-world phenomena is called mathematical modeling. Such formulas, together with the meaning assigned to the variables, are called mathematical models. All right, so our last example for this section. A bowler's handicap, which is denoted by H, is often found using the following formula. H equals 8/10 times the difference of 200 and A, where A denotes the bowler's average score. So just, basically for a handicap, you want to kind of even things up. All right, so if your average bowling score is 145, let's figure out your handicap. All right, so here, H, remember, is equal to 0.8 times 200 minus A. Well, A was the average score, and what was the average score? It was 145. So remember here, A was the average score. Our average score was 145. So this will be H is equal to 0.8. We need to do the parentheses first. So that'll be times 55. So H will be 44. So the handicap would be 44. So what does that mean? Well, your final score, if you scored 120 in a game, bowled 120 in a game, you would take that 120, you'd add to that the handicap, right? What you got for the handicap. And you would end up with your adjusted score of 164. So remember, the 164 is what we got for the handicap. I apologize, the 44 is what we got for the handicap, and when you add that to your average score, you get your final score. And that's it. You just finished your very first section. Have a fabulous day.